And this is my submission for the code resurrection. I chose the port of the original TinyExpr library from C to Rest, which was taken from the pre-beta repo pool. And the TinyExpr is a very small mathematical expression parser. It evaluates expressions like 2 plus 3 times 4 square root of 16, sine plus pi divided by 2, powers, logarithms, and many more. Instead of just translating the C code line by line, I just redesigned it using an idiomatic rest while preserving the original grammar and behavior. So first, here is my project structure. Here's the project structure. Inside SRC, each module has a single responsibilities. It's the AST.rs, which defines the asymmetric syntax tree. And then there is a built-in.rs. It implements the mathematical functions, errors, which contains the error types, evaluation.rs, which evaluates the expressions. Then there is lexa.rs, which converts the text into tokens. Live.rs, which exposes the public API. Optimize.rs, which performs the constant foldings. Parse.rs, the parser builds the abstract syntax tree, which is AST. And then there is a token.rs, which defines all token types. And then here is a test folder, which contain the test directory contains integration tests, including a port of TinyExpr's original smoke test suite. The benches directory contains the criterion benchmark. And then there is a README. The execution pipeline is straightforward. A source expression is first tokenized by Lexer. The token are consumed by the recursive descent parser to build an abstract syntax tree. The tree can optionally be optimized using a constant folding. Finally, the evaluator recursively completes the results. So we'll be with the token.rs. The tokenizer recognizes numbers, identifiers, operators, parentheses, commas, and the end of input marker. These are represented using the Rust enums instead of the integer constants as in the original C implementation. Into an lexa.rs. The lexa scans the input character by character. For each character, it decides whether it begins a number, identifier, operator, or a punctuation token. Instead of a pointer arithmetic like the C implementation, the Rust safely iterates through characters. It also skips the white space automatically. Parser.rs, this is the core of the project. The TinyExpr uses a recursive descent parser, each grammar rules corresponding to one trust function. Just parse list, parse expression, the parse term function, parse factor, parse power, and parse base. The operator precedence naturally emerges from the order of these functions. The expression handles the addition and subtraction. The terms handles the multiplication and division. The factor handles an exponentiation. Literals, variables, function calls, and parenthesized expressions. When the parser encounters a function call like a square root of 16, it parses the arguments recursively and constructs an function. Here is an AST.rs. Instead of using the C tagged unions like in the C complement implementation, Rust represents expressions using enums. Just expression, number, variable, unary, binary, function, and sequence. This makes the invalid states impossible. Each expression's type stores only the data it actually needs. Here's an evaluator.rs, eval errors. The evaluator recursively walks the asymmetric syntax tree. For numbers, it returns the value directly. Variables are looked up from the hash map. Unary expressions evaluate their operands first. Binary expressions recursively evaluate both sides before applying the operator. Functions expressions dispatched to the appropriate built-in implementation. In this eval function, the maps built-in names like square root, sin, sine, cos, wow, power, factorial, permutations, and combinations to the Rust standard mathematical operations. Or else, before evaluation, constant expressions can be simplified. For example, 2 plus 3 times 4 becomes 14 during the compilation instead of a runtime. And then the error handling, which is in error.ors, the expression return the integer error codes. This Rust version instead uses a strongly typed enums and result values. This makes failures explicit and much easier to handle.